Hi, so today we're having a look at one of these USB power banks. Now this is one I got off eBay. It's a little cylindrical type device. We've got our outputs and input there. This one is branded, I think it's Tonbix, Tonbux. They seem pretty generic. There's plenty on eBay for, if you get them from China, for I suppose about £1, £1.50, really cheap. These ones, they don't seem to have any brand name on it. This one's got a brand name, although it probably doesn't mean anything at all. This is the listing here for the item. External 2600 milliamp hours, external power battery bank, charger for iPhone, Samsung, etc. This one I paid £3.39 with free postage. Was that outside? I think that was UK. I don't think I brought that one from China. So anyway, let's have a closer look at this item. So like I say, so here we have the USB output. This is our USB input. Doesn't really have anything else on it. It's just a nice metal tube. The device itself is basically a 18650 battery. Let's put that back in there. 18650 battery that's basically connected up in here. So we can take it apart. We can see this is the inside of the unit. Everything's rolling off now. That's our 18650 battery. I don't believe this battery has any kind of battery protection circuit built into it. I think it's just a standard 18650 battery on its own. Don't know the quality or anything, but so far it's working fine in the tests. And this is our little board here, which we'll actually can take it out if we want to. There we go, a little board there. So basically the chip on it we've got is it says MP3 401 15, that's 05 or 06 A2. Now I can't find much out about this chip apart from just some information on some forums looking at these little devices and what kind of chip they have in them. But from doing my tests on it, it does seem like it's definitely some kind of charging controller, obviously, and I think it does have some form of battery protection in it as well. The battery itself, it will shut off. I don't know if I wrote it down there. No, I don't think I wrote down the cutoff voltage, but I think it was around 2.6, I think, something like that voltage, where it cut off. So it seemed to be within the specification of what it should do, and it that was on a discharge cutoff, and the charge cutoff is just above 4.2 volts, which is correct for these cells. So the usefulness of this, of course, is this circuit, like I say, does seem to be fine, and obviously you could just go and get another battery if you wanted a better quality battery with its own built-in protection as well, because it's got that kind of lip on it, which kind of makes you think it's got a board built in there, but I really don't think it has with this one. So unless I sort of took all this off, I can't really tell, but I doubt it. It might have, who knows. Anyway, so that just pops back in here. The device itself gets warmish when charging, but nothing too hot. The chip itself does get quite hot. You wouldn't want to touch it, it's a bit too hot. But with it in its case, it seems to be fine. The battery, say, that gets warmish as well when it's charging, but so far there's been no issues with any smells indicating it's going to start melted down. It's not caught fire, obviously, it's still here. I've charged it and discharged it quite a few times, and so far no problem at all. Now I've been making some notes about the figures for this, which before I get onto that, I'll just point out that obviously this one, maybe searching for that brand name there might be useful if you want to buy one of these, because there does seem to be lots of different varieties out there, and I don't know if they've all got the same charging chip, and judging by the forums, some people have sort of said that there are some that do seem to have really dodgy chips in them, and they're just, you know, dumping the voltage straight out of the battery and just charging it straight back up, and unless you put in a protected cell, you're probably going to ruin the battery and risk causing a explosion or fire, etc. So the device itself, it charges at around 1 amp. It's not completely at 1 amp, but it's normally around 1 amp. I think it's actually rated for 800 milliamps charging and 800 milliamps maximum for discharging. Charging time, this was taken basically charging one battery bank to another battery bank. This is using my Porta Power one. A little bit more about this later. So our charge time was 4 hours and 26 minutes from totally being flat. Our total power was 11.754 watt hours, which is basically 2,400 milliamp hours, so 2.4 amp hours is what it took in. Now it's rated at 2,600. I think this was the first main charge I did. With these things it does say to sort of charge discharge about 3 times to get the full capacity. Charge voltage I got there was 4.179 volts. Now the standby current draw, I took the thing apart and I connected the multimeter in line with the battery. Its standby current draw seems to be between 10.9 and 11.9 microamps. So not too bad, quite small current draw. It just seems to, it alternates basically. It would sort of be 10.9, then it jumps to 11.9, goes back to 10.9, just keeps doing that all the time. So I think it should last a reasonable amount of time without being charged. Now some discharging, discharged it. I think that was dumping the power back out of this into the other battery pack. Was 1 hour and 35 minutes at 1 amp. That was 6.930 watt hours, and the total milliamp hours there was, so where are we, 1,590 milliamp hours. That's 1.59 amp hours. What have we got there? 3.291 volts. Don't know why I wrote that down for. I don't know what that voltage was relating to now. I'd imagine that is actually probably the cut-off voltage. I might have been wrong about the 2 point something volts. I think that was probably the voltage when it fully discharged. Now on some other figures. Raspberry Pi version 2. I decided to see how long that would run for. We got a total of 1,600 milliamp hours, and that ran for 6 hours and 20 minutes. And the other one I tried was a Arduino Uno. That one we've got again 1,576 milliamp hours. So you notice we got 1,600 with the Raspberry Pi 2 taking 6 hours 20 minutes. With the Arduino we got 31 hours and 7 minutes, and we got 1,576. That's obviously losses in the device itself. Now talking of losses, I've calculated it to be around 810 milliamp hours that it seems to lose. That's between the total it takes in, which is around 2,400, 2,500. It's rated 2,600. Probably after using it a few more times it might start taking that in. But the amount I'm getting out seems to be around 810 milliamp hours less than what I'm putting in. So for efficiency wise it's not very good. I think it was rated as being about 80% efficient. Well, I'm not too sure my percentages there, but I think that's probably it's looking more like about 65% efficient, I would expect, something along those lines. The device itself, when it's operating, you've just got a static blue light. It lights up blue. So if we connect something up to it, I'll connect this power bank up so we can get the device to power up. As you can see there, we've got the blue light there. That blue light will flash rather rapidly once the battery is at near its end, and then of course it will cut off. When the unit is charging, now note that when you unplug the device, the blue light does stay on for a while until it detects that nothing's plugged into it. When we plug in to charge the unit, as you can see we've got the red light there flashing to indicate it's charging. Then when it's fully charged, the red light will just come on static. Now if we plug it into this power monitor, this is a power monitor I've been using to do my measurements on. I've got another power monitor which will be coming up in a video soon. This one I prefer because it doesn't actually take any power from the device. It's got a built-in battery pack itself, so the reading should be more accurate. We're not wasting power from the battery by running this device itself. So the voltage coming out, we've got 5.065, so that's fine. Now if we plug this power bank as a unit to charge, we can have a look at the current draw that it's providing. I'll just plug that in there. There we are. So as you can see here, we're drawing 0.98, so near enough. So 970 milliamps, so near enough 1 amp there, which is coming out of it. So what we can do now is swap it around while it rolls off the desk. This way we can charge it and see what the charging current is. The charging current won't be very high at the minute because this battery is more or less fully charged, and as you can see there, yeah, we're only getting 170 odd milliamps, and of course that will drop down as the battery becomes fully charged. Now, as far as running things, as a rough estimate on charging, I was with my friend, we were going up to the Classic Car Motor Show a couple of weeks back now, and his phone, he's got a Samsung Galaxy S4, and that was at 50%, so while we're in the car I gave him that and just said we'll try it. I don't know if it would give you much charge or not, going by my current results in testing, but anyway, he plugged it in and he got from 50% up to 100%, and there was still a little bit of power in this, but not much, because I did plug my phone in and I got all of about 3 minutes. So I would say you're probably looking at being able to charge a sort of modern day smartphone, probably about 50% charge with this device. Now, what I find is quite a useful feature of this is, whereas this one here, this is rated at 10,200 milliamp hours, and again it's not super efficient, but it's not too bad. I can't remember the results for this. I'll need to do some further testing and perhaps do another video dedicated to this one here. This one's obviously a lot bigger, a lot more bulky. This one's nice and light, carry it around easy. This is a bit too bulky for that. But the problem is with these, as you get with some, and it's very hit and miss as to which one which type you're going to get when you buy one of these battery packs. Is basically some of these battery packs, they require a certain amount of current draw to operate, and if they don't receive it, then they will turn themselves back off. So if we take the Portapower one here for an example, if we plug that into our Arduino Uno and we turn the battery pack on, as you can see, the lights are on there. Try and cover that up a bit. You can see that's just running the blink program there. Now what we find is we shouldn't get too long of that running, and this pack will actually shut itself off. So you can see there it's operating. You see the lights are on the power bank. So we're just waiting now for that to go off. I don't think I've actually ever timed it as to how long it is, but I don't think it's that long. Might be a minute, possibly. There we are, it's off. So now the Arduino stopped working. Now this of course is a problem if you're, say, building, you've got, say, a project you're using with the Arduino and you've not powering much of it, and you think, oh, ideal, I'll just use one of these giant power banks as a way to run it while I'm doing some tests or whatever you're doing with it, or you want to, say, have it a bit more portable, etc. Then of course you plug it into one of them and the thing turns itself off. This on the other hand doesn't, which is very useful. If we plug that in there, we can see our Arduino board there is running. As you can see there. And the battery pack itself, it's such a low current draw that the battery pack hasn't even put its light on. Let's say normally got the blue light that comes on, but that's not even on, which might be useful, I don't know. But yeah, it means that basically this will happily run for, well, where do we get? 31 hours and 7 minutes, roughly, just running an Arduino with just the blink program running on it. But you'll see what I mean. If we plug it into our charger monitor thing here, we can have a look and we will see that there we are. Current draw at the minute is 0.05 of an amp, so 52 milliamps that would be, wouldn't it? Yep, so yeah, 52 milliamps. So I'm not quite sure what, with like these chargers like this one, what the minimum draw is that will keep it on, but this is just useful in that sense, that because A, it does seem to run an Arduino quite a long time, but I've not tested it with, say, running a sketch, doing something else with other things connected like sensors, radios, etc. So I don't know quite how long it would last with all that connected. So as you can see, not too bad, and I'm rather pleased with it. For the price, it's good. It seems safe enough. You know, that's the first thing I did, was to check that it was going to shut the battery off at the correct point, and that it was, you know, for being fully charged, and again for discharging, so you don't under discharge it, because lithium cells, if you under discharge them, you pretty much ruin the battery and it's not going to really perform properly thereafter. So I hope you found that video useful, and let's say if you did a search on eBay for that one there, so I think that's Tonblix, that could be TAN, Tonbux or Tonbux, or just search for USB power bank or 18650 USB power bank. You want to be looking for something like that, and ideally with that brand, because hopefully that means that they do contain the same chip inside. And as I said earlier, the good thing about this is, you know, with this one here, if the pack fails, if the cells die, you can get it apart, but it'd be very awkward trying to find some cells to replace it with. At least with this one, you can just unscrew it, pop in another 18650 battery, and you're ready to go. Thanks for watching.